I'm Víctor Izquierdo, the Deputy Head of the Solar Energy Materials and Systems Group at IREC, and we are very excited to coordinate the Platform Zero project.
Platform Zero is a project co-funded by the European Commission that aims to substantially reduce production costs for industry in the photovoltaic sector. The high complexity of the latest generation of PV technologies makes them prone to the appearance of critical defects, with just small deviations from standard manufacturing conditions leading to significant production waste. Platform Zero addresses this challenge by developing a new customizable inline process monitoring platform to reach zero-defect manufacturing. Platform Zero will implement advanced sensor stations, an artificial intelligence system for autonomous monitoring and control, a big data management infrastructure and control system, and a functional process monitoring platform to obtain optimized manufacturing of PV modules. This strategy will be tested in 4 different PV industrial pilot plants throughout Europe, in Spain, in Poland, in Austria, and in Germany. Platform Zero will contribute to increasing the overall quality and reducing the cost of high-tech PV devices, increasing the competitiveness of the EU's PV industry, and allowing this green technology to become a key energy source for Europe's transition towards climate-neutral energy generation. Platform Zero is a consortium of 12 European partners from 6 member states. Follow our research progress on our website and on social media.
The first modern wind turbine blades was made in the 1970s and were only a few meters long. Today, the longest wind turbine blades are more than 100 meters long, and thousands of wind turbine blades are installed in Europe every year. Over the years, there have been made major improvements of the manufacturing technique of wind turbine blades. Nevertheless, the manufacturing technique still relies heavily on labor works and with limited inline controls, and in addition with limited possibility for non-destructive characterizations. This leads to a certain level of defects with requirement for repair and with a certain level of scrap rates.
Turbo is a Horizon Europe project which aims to improve on this baseline. Led by DTU, the consortium brings together agencies and companies and universities from across Europe to tackle this challenging problem. In Turbo, we take a holistic approach and try to bring together advances from several different fields, not only to reduce the number of defects, but also improve on repair strategies in wind turbine blade coatings and composites. In Turbo, we not only want to detect the defects and to remove them again, we also want to understand the physics of them and why they appear in order to really, in fact, completely remove them. We will use the latest simulation techniques based on the numerical framework of ESI and the reduced order models of DTU Construct. This will allow process optimization and to avoid defect formation, and it will allow to understand the defects and how they influence structural integrity.
A key area of novelty of the project is to develop 3 cutting-edge NDT systems in parallel. These systems will be used to monitor different aspects of the production line and to provide system-level data. Working with DTU Wind, synthesites are developing 2 measurement systems, firstly a dielectric system and secondly a sensorless mercure monitoring system. CPI will develop embedded wireless sensors that can directly monitor temperature in the blade structure.
We will develop subsurface wind turbine blade coating inspection, since high-quality coatings are essential for the blade performance. Turbo will combine infrared thermography and the new technology mid-infrared OCT developed at Nobles based on subcontinuous sources developed at DTU Electro. These 2 approaches will be integrated into a single robotic system located at the UK National Composite Centre. The OCT inspects the critical upper layers with high resolution, where thermography inspects the deeper defects in the coating, thereby getting the best inspection in the world.
Using techniques developed at Smartia, we will combine equipment data, NDT data, and inline monitoring data to build a digital twin for online monitoring of a production process. This has never been attempted for a large-scale composite part. In the future, the system will populate a data warehouse that will be accessible from multiple production sites.
Using the digital twin and lessons learned from the simulation work, a machine learning-based algorithm will calculate process control signals on the fly. This will optimize the system in real time in order to minimize defect formation and waste and optimize process efficiency. The algorithms will be trained on the contents of the data warehouse, so that the results are constantly being updated and improved based on many real cases of production processes.
At the end of the project, all of these technologies will be brought together in a demonstration of over 80 meters long wheel turbine blade section.
Increasing the share of renewable energies is definitely part of the solution to a correct energy transition. But we need to make sure that wind turbine systems are manufactured in a safe and sustainable way. Turbo will positively contribute to this objective. RDTech will lead the task of sustainability assessments, including details LCA for the environmental, LCC for the economic, social LCAs, and circular pathways. So we will demonstrate the environmental and socioeconomic benefits of Turbo implementation.
More information is available at the project website, and we have a LinkedIn group. Please send us an email if you would like to join the Turbo community to receive the newsletters and updates.